Alrighty, so this is a very similar question. It's just one that involves sine and cosine. So the first thing I'm going to do is graph sine and cosine. So sine, this is already in terms of pi's, right, which is nice because those are the even numbers. So we should know that sine of 0, and again, you can do this with an xy table if you want. But we're going to use these increments, right? So sine of 0 is going to be 0. That's here. And then pi over 2 is going to be 1. And what we'll do is end up with something that looks like this, right? Okay, that'll go on forever. So this is f of x. And then g of x, I'll try and do in a different color here. We know that cosine, again, you can do xy, right? But cosine of 0 is 1. So we know cosine starts here and goes downward. So it'll end up being here, and here, and here, and up here, right? Where this is 1 full cosine, okay? And it'll keep going down. But again, we don't really care about that, but this one is our g of x, okay? So looking at this, it says find the area of one of the regions bounded by the graphs, okay? So the only thing that's different here is now you see there's multiple regions. It could be this region here. It could be this region here. It just says 1, so it doesn't matter which one we do. So let's take a look at this first one here, right? Okay, so we need to find the area. It's the integral from, all right, here to here. And that's the one piece of information that we don't have, okay? Now, when we don't know the exact endpoints here, like we could tell when we plotted it up here in that other example, what's really happening is these are where the graphs are intersecting, right? So mathematically, they're meeting each other, right? They're meeting each other. So how do we do that algebraically? Well, we just set them equal to each other. So I'm going to find our endpoints by setting sine and cosine equal to each other. And essentially, we're solving for x, okay? So this is going to take some algebra, whether or not it's trig or a typical equation. So what I'm going to do is divide by cosine. This will turn into 1 equals, well, sine over cosine is tan of x, right? Oops, tan of x. Okay, tan of x equals 1. How do I find x? I take the inverse tangent of both sides. So the inverse tan of 1, right? And that will give us x of, and you want to make sure that you are dealing with radians, so that's going to be pi over 4 and 5 pi over 4, okay? So those are going to be my endpoints, pi over 4 and 5 pi over 4, and those make sense based on the graph here. So from pi over 4 to 5 pi over 4. I'm going to take, again, the top function right here, which is sine, and subtract the bottom function, cosine dx, right? And we're integrating, so you can integrate separately. The integral of sine of x is negative cosine x. Integral of cos, but there's a negative, it's just positive sine, so minus sine of x. And we're integrating from pi over 4 to 5 pi over 4, okay? And since this is a free response, I'm not going to simplify, but again, we need to do the fundamental theorem of calculus, f of 5 pi over 4 minus f of pi over 4, okay? So I'll put it in, but I'm not going to get, I'll write the final answer, but I won't simplify this all the way out. F of 5 pi is negative cos 5 pi over 4 minus sine of 5 pi over 4. And then f of pi over 4 is negative cos pi over 4 minus sine pi over 4. Okay. When you go through all of the trouble of simplifying using your unit circle, you should get 2 root 2. Okay. Alrighty, one more example.